the work of the bearing. So, and then the shaft is supported by two types of bearing. One bearing type at B and one bearing type at D, as shown in figures. So the belt tension F1 is 450 Newton and F2 is 200 Newton. And the gear forces are FT, F3, 1200 Newton and F4 is 700 Newton. So the system will last until 25,000 hours and both bearings are 98% reliability. If the bearing D is designed to support a thrust load of F5, 580 Newton, determine all the suitable sizes of the roller bearing and angular ball bearing for the shaft. So for this question, this type of question, definitely we have to, the first thing we have to get the reaction force. So any bearing problem, the first part is to solve the reaction force acting on the bearing. So from that reaction force, actually we calculate, we could determine, and at the end we take that reaction force which acting on the bearing, then that forces will be as a forces acting on the bearing. So any of you have tried the questions? All right. So the first we have to calculate the radial loads acting at bearing B and D. So this is the shaft and this is the location of bearing D, and this is the gears, and this is the pulley. And then this is the bearing B. So A, B, C, and D. And you see that the axis, this is Y, X, Z. This is 45 degrees. This is 45 degrees. So we have to calculate the radial loads here and here. So first take the edges of X, Y, right? It's X, Y. Then X, Y, and this is the load, right? So this is A and B, C, and D. A is this one, the forces, and then RB. RB, let's say this is this RB, reaction force at B, and you have F3, right? So here you have this one and that one, F3. So F3 upward, F3. Then anyway, for the reaction force, you just put any direction. So when you get the minus value of the forces, so our assumption of the direction of the force is wrong. So you need to turn the direction. So this is RB. So take the equilibrium of moment at D. So moment D equal to 0. So this one F1 plus F2. So F1 plus F2 minus direction, both 45 degrees, and this is 80, this is 120, and this is 100. Total is 300. Then RB, time 220 plus F3 times 100 go to 0. So you know F1 is given, F2 is given, F3 is given. So then you will get RB, right? So you will get RB in the direction of Y, RB in direction of Y, RBY. Okay, this is RDY. Okay, Y. Okay. Then here you will get RBY is equal to 81.3 Newton. So then the second one is the equilibrium of forces to 0. So minus F1 plus F2 time sin 45 degrees plus RBY plus F3 minus RDY go to 0. So RBY, you already calculate, we have already calculated RBY. So then here you will get RDY. So RDY is equal to 821.7 Newton. So this is the Rx, the axis XY. Then another axis is from the top, which is XZ. XZ. So from this axis XZ, so you will get the another axis. This is A, B, C, and D. So this is, and then reaction force are P, Z. Then you will have F4. Then another reaction force, which is R, D, Z. Then take the moment of at D, go to 0. So again, another direction, F1 plus F2 cos 45 degrees times 300 plus RBZ time 220 minus F4 times 100 equal to 0. So F1 given, F2 given, RBZ, okay, and R4 is given. So here you will get RBZ. 944.9 Newton. Then equilibriums of forces equal to 0. So F1 plus F2 minus cos 45 degrees plus RBZ minus F4 plus RBZ equal to 0. This is RBZ being calculated. Then here you will get RBZ, which is 214.7 Newton. Okay. So radial loads at bearing B, RBZ and RBY. So RB, total RB, radial loads. So RB 81.3 squared plus 944.9 squared. Then you get the value 848.4 Newton. Then RD, okay. Then radial loads. At bearing D. So RD radials equal to 8217, 821.7 squared plus 214.7 Newton squared. Then you will get 849.26 Newton. Okay. So once you have calculated the radial load at bearing B and D, so you could start determine the size of roller bearing and angular bearing. So the question mentioned that thrust load at D. Okay, thrust load at D is equal to 850 Newton. Okay, this is thrust load. This is radial load at B and radial load at D. So we know that the roller bearing only supports radial load and angular bearing thrust plus radial load. So for it means that in at B here, so you need to use the roller bearing. At B, need to use roller bearing. At D, you need to use angular ball bearing because it has thrust loads. It, oh no, this is 580, not 850. 580, 580. Okay, so at B, at D, since D you have radial load and thrust load, you need to use angular bearing, angular ball bearing. For B, just radial load, so you could use roller bearing. So first, calculate the roller bearing. So first, determine the size of roller bearing, bearing B. So FB radials, you have calculated total is BR 948.410. So then another one is the impact is moderate impact. Take the lowest one. So you could see the tables. Okay, so this is KA. So this is KA equal to 1.1. So then another one is reliability, 98%. This is KR. Okay. KR, you could identify from the graph, so 0.35. So for the CRQ for B, the formula is KAB, KA time FB times LKR times LR 0.3. Okay, so L is given, all given. So lifetime 200, 2000, 2000 RPM times how long it the system run 25 hours times given is 25 hours 60 convert, okay, 25 hours, then convert to minutes, 60, then you get 300. How many zero? 0, 0, 0, 0, 0, 0, 0. Evolutions. So for the standard one, LR is equal to 9 times 10 to the power 7. So just insert all the value, KA, FB, you have FB, L, you have L, and LR, you have LR, and KR, reliability, you have then power of 0.3. So then you will get is equal to 40. Okay. So berapa dapat Sekejap, saya kira je. KA 1 times 4 points. box 1. And 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 0.35. Nine times 4,000, 4,000, 4,000, 9, 3. Okay. Okay, so from this value, so you could go to the tables. Okay, go to the tables. Saya buka table dia. Eh. 4.093 kilometer. Okay, 4.093. 4.0, 4.0 means radial ball bearing. So 0 degrees roller. So this is a roller. This is radial ball bearing. This is the angular ball bearing. So for the roller ball bearing, so 4.0, 4.0, 4.0. So somewhere here. So take 40 and for 12,000 series, 4.0. So take this one and this one take 17. Okay kelas ni boleh eh? So for you calculate the rated score, rated capacity, the load, rated capacity, then go to the tables. So either roller, okay, this case is roller. So then next is angular, if angular ball bearing 25 degrees. So get the suitable rated capacity. If the radial ball bearing uh, alpha equal to 0, so get the suitable uh, series. Okay, because dalam table ni 14 is in 14.2 table, it has three types of bearing. Three types of bearing. So from that rated capacity yang you dah kira, so you go to this table and then get the suitable series. Then after that you get the suitable ball. The ball. Boleh?
Doktor,
Hmm.
daripada 4093 kita dapat 4
You kira dapat berapa?
okay. Sama je doktor. So we just make it in kilonewton lah doktor.
Ya, 4.0, 4.1 lah.
Okay, doktor.
4.0, 4.093. Okay, 4 points. So, kalau roller bearing, kalau nak gunakan 1000 series, one series sebenarnya. So, you gunakan 40 ball, 40 milliliter ball. Could support 7.2 kilonewton. So, in your case, in between. Alright? Okay, saya semula. So, for the roller bearing, you akan dapat for 1000. Okay, this for roller. 1000 XLT. Ialah 7.2 kan. So, bore dia 40 mm. Okay, kemudian LT dapat 4.4, bore dia 20 mm. Kemudian medium but 4.9 and border 17 mm. So daripada that bore 40 mm, zero 08. So this is 1. So you will get 1008. So then for 20, to series 04. You dapat 1204. Then this one 1303. You dapat daripada mana you dapat this value ni, you go another table. Okay, you turn to another tables. Tadi you dapat roller bearing. Let's say ambil roller 40 kan. Okay, this for roller for 40. For 1000 series, 10, okay, 1000 1000 series. So 40 ball for 10. So go to the another tables. 40 is 40. Nampak kerja saya kan 40 ni. Kemudian dia punya basic number dia L08. Okay. So you just tambah 1008. Kemudian yang the next one 20 ball, 20. So 20 untuk yang 2000 series. 20, so 20, so you just tambah 1204. 04, this one. Another one is 17. 17 for 3000 series. So dia tambah 1303. Yang inilah. Okay, boleh dapatkan that value. How the value is coming from. Okay. So the first one, once you have calculated the radial forces, radial loads, kemudian you use the formula get the rated capacity. From the rated capacity, so the rated capacity, so you tengoklah mana yang bearing mana yang you pakai, radial, angular or roller bearing. Okay. Kemudian you tengok mana you nak pakai which series. Okay, let's say ambil yang tadi contoh dia for those roller bearing take all 3 series. So mana yang supports? So you kena ambil the maximum value. The maximum value. Okay. So you dapatkan the ball. The ball tu kan. So that ball tu you go from that ball you go to the another table, 14.1 table. So then get the ball size, and this is the series one. Kan 1000 series, 2000 series, 100 series. So you ambil lah the value ni. Value ni mana? Okay. Okay, the next one. For the angular ball bearing. So for the bearing D, which is angular ball bearing, alpha equal to 25 degrees. So given is thrust load, yang you calculated is FD. So this is coming from that you have been calculated. You have been the value is been calculated. So you dah dapat value tu ialah FD is equal to okay, let's say ambil 850. Okay, ambil 850 LA. Dah kira 850 Newton. So the given thrust load F5 given 580 Newton. Okay, so you need to uh, calculate the equivalent radial loads. Okay, you need to calculate the equivalent radial load yang ada formula FE. And so the value is if you need to get the ratio between the ratio the thrust load and the radial loads. Okay. So the ratio is x equal to FD thrust load divided by radial loads FDR. So if the x value, the ratio is between 0 to 0.68. So you take the equivalent load is equal to F just radial load just take for radial loads. If 0.8 x to 10, so for FD needs to times 1 plus 0.870 times x minus 0.68. Okay, the formula is given in the slide. Andai kata x more than 10, so your FD should be multiply with 0.999. Okay. So this FD thrust load 580 divided by 85 0, approximately 682. Yes. Okay, so which formula that you have to take? The first one, second one, or third one? So it just additional two. Okay, so you could pick. Okay, yeah, you could take this one because even though the extra value 0.002, just take that value. Not much, that value not much compared the first and second value. Even though you could take the first formula as well, because the extra 0.002 not much. Okay. So let's say you take the second value. Okay, the second value, then FD is 840 times 1 plus 0.870 times X 0.862 minus 0.68. Okay. Then you get the value of Fx equivalence Ex equal to 851.74 Newton. Okay, then just repeat the calculation for moderate impact. So you get the calculate the moderate impact from the table. Okay, take a look from the table. Okay, application factor KA table 14.3. Moderate impact. So for roller bearing, previously the lowest that we take is 1.1. For the ball bearing, 1.5. So this is the value, the factor that we take from these tables. Okay, formula ni ada dalam untuk test tu. Saya ada bagi untuk test tu. So reliability factors sama. Okay, dapat reliability factors 98 about 0.35. Right. So you akan dapat KA equal to 1.5. Then KR, reliability factor, KR sama 0.35. Dan LR semua sama. Okay. So you just need to calculate the rated capacity C for D, which is KA times FD equivalent. Equivalent. Kemudian this one also sama, KR times LR. Then you akan dapat 5,012.4. So pergi pada tables, angular ball bearing untuk alpha equal to 25 degrees. So this one 5.01 kilonewton. Okay. So you akan dapat from the table L00 XLT equal to 6.3 kilonewton. Then you akan pergi pada bore dia, bore equal to 45 millimeter. Then 200 series LT equal to 6 kilonewton, and bore is equal to 30 millimeter. And 300 series median 5.8 kilonewton, then bore is equal to 20 millimeter. Okay, kemudian you go to another table to get the basic numbers. So basic numbers, so you will get L for the 100 series L09, 100 series 206, and then for 200 series 304. Okay, then. Any question, class? Most of the question dalam untuk bearing, most of the question macam ni lah. Kan? The most important, you need to calculate how uh, the reaction force on the bearing from the either gears, pulley, okay.
Doctor,
Yeah.
for the reaction force we calculated earlier, we didn't consider the diameter of the pulley or the gear because of why, Doctor?
Didn't, sorry?
Normally when we're doing a reaction force for a pulley or a gear, we will consider the diameter, right, Doctor, for to calculate the moment, etc. It's like
Because we don't calculate torque.
oh, okay, Doctor, that's the reason. Thank you.
We just calculate the moment. Moment tu maksud dia we fix any point. Okay, then 90 degrees from the forces, then you, because we don't calculate torque. Later, the next question, you need to calculate the torque. It depends on the question. But here, for the moment, no need to use the diameter of the pulley. If diameter for the pulley and diameter of the gears normally stock. Okay. Okay. Dah soalan Okay, this example. So the next example saya akan give brief lah. Next example.
Betul.
Yeah.
So final answer ada 3 jawapan lah maksudnya. Macam
Yeah.
okay.
Final answer 3 jawapan yang kita boleh guna untuk standard tersebut. Kecuali kalau dia beritahu certain series lah. Tapi kalau tak beritahu, maknanya kat situ ada 3 could use in one of those bearing lah. Kecuali dia dah bagi bore dia, size bore berapa. Okay, size bore berapa, so nanti you kena pilih lah size bore yang sesuai. Kalau tak ada size bore, the bore size for the shaft not given. So the shaft could be 45 mm, 30 mm, and 20 mm. It could be any diameter of the shaft to fit the bearing. Otherwise, there is another requirement given to you, either shaft size or numbers of bearing, for example. Basic calculation, basic macam ni. If given another requirement, it's different. Okay. Okay, so kita tengok soalan lah satu lagi. Contoh soalan satu lagi. Okay, the question is the speed, the gear speed reducer. Okay, ini motor. This is a motor. The gear speed reducer represent in figure Q1 is driven at 1000 RPM by motor. So developing 21 kilonewton, which means the power is 21. Power is 21 kilonewton. Okay, the teeth have certain angle, this angle. Pitch diameter for the pinion, this pinion, 70 mm. Diameter pitch for the pinion, and for the gears, 210 millimeter for the gears. So the load are uniform with no impact. So the selected bearing must have 90% reliability and must be serviced in 1 year, 52 weeks without breakdown for 24 hours per day. Continuous weekly operation. Ini you nak ganti kira L lah. Okay. So dalam soalan ini this is axial load direction with respect to pinion. So this is tangent FT untuk pinion. Okay. This is FA. This is FR. So the formulas given. Formulas given. Tak jelas lah This is for FA equal to FT and this is FR equal to FT. Cos okay. So you have learned that this FT, this FA, this FR. Kan? Bila belajar gear kan? The first question determine the magnitude and direction of three gears tools forces acting FA, FR, FT on the pinion dan gear. Kemudian make two isometric sketches and one for pinion and one for gears, showing all these forces with the correct directions. Okay. So this talk, okay, ini talk yang you perlu guna. First, you kena cari apa? What you are going to search? First, you are going to search for pinion. Okay, pinion. Pinion. Okay, this is the pinion. And this is the shell. This is gear. Good. Okay. Kemudian radial dari sini lah radial. So tangential biasanya dia akan memusingkan, rotate. So this is rotation. It depend how you look. How you look. Macam mana tengok nak pusingkan Saya nak draw ni. Okay. Kita draw. Kita draw secara depan lah. Okay. So ini you punya FR. This is FT ya. So ke sini ya. Yang dia tak nampak ni FA. Nampak. So you need to calculate what is the F. You need to calculate what is FA, what is FR, and what is FT. For pinion first. This for pinion. So given is power. Kalau you kira power, macam mana kira power? Relate power and torque. How to relate power and torque? Power equal to torque omega. So then torque equal to power omega. Betul. So this given, this is given. Then you convert. The thing is you need to convert the unit. The thing is you need to convert the units. Okay. I just give the answer because we don't have much time. So for the torque, this is the formula. Okay. This is 190. .98 meter. So to convert the unit from because the unit given is kilowatt, right? The unit given is kilowatts. So this is the units given is kilowatt. So this is kilowatt divided by RPM. So you need to convert unit kilowatt RPM becoming jadi apa? Newton meter. So to convert this unit, you need to calculate with the value of 9,959. Just this conversion tak ada just formula of conversion. So you carilah macam mana nak convert, how to convert this value to torque. Okay. So then you get the value of torque. So you know that torque is equal to Fr. This F for gears is F tangential force. So here you will get tangential force for pinions, torque divided by R. Dah kira torque dah ni. So this is R. Then you convert, tukar jadi daripada radius to diameter. Pitch them given pitch diameter for the pinion. So this T torque for pinion kan. Kemudian 2 darab diameter for pinion. Convert the value. Conversion. Millimeter kan, dia bagi given millimeter. So convert. Then you akan dapat 5457 Newton. So the basic formula yang you perlu tahu lah, this basic formula. This is the basic formula. So then you dah kira FT ni. Untuk pinion. So once you dapat FT, once you get FT, so just insert to the formula given, which is FR. FR ialah FT darab tangent. Tangent 20.05 divided by cos 28.65. Then you get the value of 2,269. Guna juga give the same use the same value of tangential force, kemudian insert to the formula given. So FA equal to FT. Formula dia tangent 28.65. Then dia akan dapat 2961. Okay, this is for pinion. For gears pun sama jugalah. For gears, for gears, this is the gears examples. This is FR. Kemudian let's say this is tangent and another direction daripada depan is FA. So the same one you kena cari torque for gears. Daripada torque for gears you akan torque for gears you akan dapat 573 Newton. And then you kira F tangential force for gears, you akan dapat 5457 Newton. Dan radial force you dapat 2. Sama juga masuk formula 9. Dan axial force you dapat 2982 Newton. Okay, selepas sudah, once you get the value for gears, barulah you proceed to calculate the reaction force of the bearing. So this is C, and this is D, and this is the gears. It's the gears. This F tangential force for gears. This is radial force. This is A. Okay. So then this is you should have this one, and you have this one. So X, Y, Z. So this is C, R, C, Y. So this is R, tak payah guna R panjang. So direct, this is CY, CZ, this is DY, DZ, and this is DX. Okay. So ini dah ada, RAZ you dah ada, calculated before. And then just need to calculate the reaction force for bearing lah, kan? C and D is for bearing. Okay, sama juga macam tadi. Get the axis. Get the axis. Mula get the axis. XY. XY axis. Kan XY axis. So ambilkan axis dia. XY apa yang ada? This one. cy dy. Then you ada fr, x value, then you ada fa. This for xy. Okay, the next one is exact. Okay, exact. Okay, this is the okay. The next is exact. So exact plane, maksud dia exact. So apa yang you ada? This is CZ, then DZ, apa lagi? T lah, T. You ada? T. Opposite. Right. So you ada. Okay. So you kira, then you will get CZ, CDY, then you get CY, DX. Selepas tu, so radial loads, you akan dapat at point D. So the radial load berapa? You akan ada D dy squared plus dz squared. So another one, you ada thrust load. You ada thrust load. Dekat point D, you ada Ft, which is dx. Kemudian at point C, so radial loads, you ada apa? You ada cy squared plus cz squared. Okay. At point C, just radial loads. At point D, you ada radial and thrust load. Sama juga yang tadi. Okay. Untuk point C, soalan dia apa? Soalan dia, select two radial ball bearing. Radial ball bearing. Okay, radial ball bearing. Maksud dia point radial ball bearing, maknanya dua-dua ball bearing lah, bukan roller bearing. walaupun at point C only radial loads applied on point C, okay, tapi the question is use radial ball bearing. Okay, radial ball bearing. Dia ada mention apa-apa tak? Tak ada. Given the torque, what are the bearing basic numbers and ball size for location C and D? If, okay, another requirement is if L00, okay, XLT series ball bearing are required. Maknanya apa? Maknanya 100 series only. So you just need to give one for L00. For L00. Okay, boleh proceed Boleh you proceed Saya bagi last saja jawapan dia. Untuk at point C, bore dia is equal to 40 mm. L00 4.5 kilonewton. And basic number L08. And point D, bore 50 mm. L00 XLT 6.10 kilonewton, and basic number L10. Radial basic number L10. Yang soalan the next question tu you cubalah fikirkan. Soalan dia, if the radial thrust load at both location C and D fluctuate by plus minus 20%, determine one appropriate 200 LT series radial ball bearing with basic numbers of for both C and D. Radial thrust load fluctuate, maknanya FR and FT increase 20%. And then equivalent radial loads also increase 20%, 1.2. Okay, so I think that just the rough ideas. Any question, class? Boleh proceed.
Doktor,
Yeah.
kenapa dekat CX tak ada reaction?
CX tak ada. Sebab dia punya forces tu ke arah lain, ke arah uh, D. Ke arah D. So beban tu dia tak kepada C, beban tu kepada D. The loads supported at D. C, there's no forces in X direction.
Tanya, mana dapat tangent 20.05 dengan 28.65 tu?
Oh, degrees tu.
Ah,
Oh, degrees tu soalan, dalam soalan. Dalam soalan. This degrees, you convert lah nanti. Kena convert.
convert means macam ni doktor?
Convert radian. Kalau you nak convert radian lah, kalau tak payah. Tapi this they given 26 and 20 degrees. Okay. Okay. This has 26 degrees. Okay. Tangent 26. Okay, change the question. That's 20.20 degrees to 28. The pi is 20. The pi is 20. The pi is 20 and the 26 tu you tukar kepada 20 dalam soalan. 28.65. Okay, dalam soalan tu you kena tukar. Okay. Okay, dalam soalan this one you need to change. Pi is 28.65 and this is 20. Dikurang lah. into it. Okay. The other process is the same. Proses lain semua sama lah. Proses lain semua sama. Okay, ada soalan lagi? Any questions, class?
Doctor,
Hmm.
yang at least 1 year, 52 weeks and 24 hours ni kita akan buat yang lifetime tu, Doctor.
Ya,
Macam
betul. Betul. Ya, betul. You kena
kira hours.
LR tu, L.
Okay, Doctor.
So, you kena convert tu convert. Sebab dia dalam revolution. RPM kan? Ni dia.
Okay, Doctor. So, kita akan convert kepada minutes.
Convert kepada minute, convert kepada, so dia punya L ni is lifetime dia is revolution.
Okay, Doctor. Faham.
Okay, pusingan, berapa banyak pusingan. Okay, so if no questions, saya ada bagi letak dalam e-learning tu. So the first question and the second question on Thursday. Thursday, kebiasaannya Thursday lah. So you ada about 4 days. 4 days untuk siapkan these two questions on Thursday. Okay. Then on Tuesday, Selasa, new topic VBELT, and also I want you to update your project. Okay, you need to update your project. Anything, if you have calculated bearing, if you have calculated something in your project, just update. Okay. Okay, class. Thank you very much.